Alright, in this video we're going to be looking at how to graph equations when they're given to us in slope-intercept form. So first of all, I want you to look at a couple of things. So if we notice that we have this first equation, it's right up here on the top left. Notice it's y equals negative 2x plus 1. The main thing that you need to remember whenever you're doing these is that when you're given an equation like this, remember this is slope-intercept form, and it's in the form of y equals mx plus b. Now m is the slope, our rate of change, and b is the y-intercept. Now this is very important because this really helps us graph these by knowing these two things. So if I look at this first equation here, I'm going to go ahead and use my highlighter, and I'm just going to circle my y-intercept. That right there, that value of 1 is my b. In other words, it is my y-intercept. So all I have to do is go to the y-axis, and when I say y-axis, that is going to be the axis that runs up and down. So I'm actually going to highlight all of them orange on the problems that we're doing today so that you understand every time I work on one of these equations, I'm always going to start by plotting a point at my y-intercept. So this positive 1, that would mean that from origin, right, where the two bolded lines cross, the x-axis and the y-axis, I'm going to go up here to positive 1 on the y-axis. And I'm going to put a point. So I'm going to go ahead and put my point right there at positive 1. My y-axis is the one that runs up and down. The x-axis runs left to right, and it's horizontal. This is vertical. So I've got this done. I'm going to put a check by it. So that is complete. Now what I want to do is I want to go ahead and use the slope. Now the slope is going to be a little bit tricky on this one if you forgot about how to turn it into a fraction. Now notice we do have negative 2. In other words, my m value, my slope, is negative 2. And in order to graph, I want to convert this to a fraction. Well, the way we convert an integer to a fraction, and when I say integer, I just mean a whole number that's positive or negative, is I'm just going to put it over 1. So this is negative 2 for my slope. So if I write it as a fraction, it's negative 2 over 1. Because it's negative, that means that we're going to go down 2 times. The numerator always represents our rise. I'm going to write the word right beside it, rise. And when we say rise, we're talking about how far we go up or how far we go down. So this is negative 2 over 1, so we're going to go down 2. Now the number in the bottom, the denominator, represents what we call our run. And that's always how far we're going to go to the right. And now you hear me say about going down 2 times and going right 1 time. I mean, you may be thinking about, well, where? Well, from the y-intercept. So they gave us the y-intercept, so we have a starting point. So I'm going to put my pin on top of that starting point, positive 1, because it was plus 1. And now I'm going to go down 2 units because my slope was negative 2. So 1, 2. And then I'm going to go to the right 1 unit because my denominator was 1. So I'm going to go to the right 1. I'm going to go ahead and put a point there. And now all I have to do is draw a line through those 2 points. In order to graph any line, all we need is 2 good points to make a line through. So let me move this up just a little bit. And this is the graph of y equals 2x plus 1. So let's do one that's a little different. If we come over here to this one on the right, notice we have a positive slope and we have a different y-intercept. Now in this case, my y-intercept, my b value is 4. So I'm going to put a b on top of it. That's my y-intercept. So I'm going to go to origin, and I want to go to positive 4 on the y-axis. So I'm going to go up 4 times. 1, 2, 3, 4. I'm going to put a point right there. Now I want you to keep in mind, if this would have said negative 4, I would have went from origin down 4 times. Right? 1, 2, 3, 4. But because it says positive 4, I'm going to go up 4 times. Now the slope is also positive. Notice this slope, it's 2, but it's not a negative 2. My m value is a positive 2. What this means is that since it is positive, we will be going up instead of down. So we're going to go up 2 times. And then we're still going to go to the right just 1 time. So I'm going to go here to my value of 4, my y-intercept, and from there, I'm going to go ahead and go up 2 times. 1, 2, and then I'll go to the right one time, 1. Put a point right there, and I'm going to go ahead and draw my line, and this line is graphed. Now, a couple things that I do want to point out is we're just using the y-intercept and we're using the slope to graph it. But I want you to know that every time that it crosses the x-axis, in other words, right here where it crosses the x-axis, that is an x-intercept. Where it crossed this y-axis right here, where that b value of positive 1, that was my y-intercept. So just keep that in mind as you see me doing these. For instance, this one looks like it crosses right here on the x-axis. So I'm going to put a line, that is my x-intercept. And on this one, it's actually, this one looks like it's in the middle somewhere, right? But this one, this is a good point. This looks like it's actually at 1, 2. So the x-intercept is at 2 in this particular problem. So there's 2 examples. Let's look at 2 more situations. Now we have 2 more problems to do, but I want you to notice this problem is a little different here. Instead of having a positive y-intercept, I want you to notice our b value is negative. So I'm going to put a b on top of it. That's my y-intercept, my b value. So instead of going up, because it's a negative y-intercept, I got to find negative 2, which is actually down 2 units. You just need to remember that when going down from origin on the y-axis, values are negative. When going up from origin on the y-axis, values are positive. Similar to if we go right from origin on the y-axis, values are positive. And if we go to the left, values are negative. So this is at negative 2 because from origin I went down 2 times. So my y-intercept is negative 2, and here is my y-intercept right here. Y-intercept. Now, I just need to put one more point and we can draw our line. Now in this case, notice that our slope, it is actually written as a fraction already, 2 over 3. And that makes it easier. So anytime they give us a slope as a fraction, it's easier to do the problem because you don't have to worry about putting 1 in the denominator. And what this means, this is a positive slope. So a positive slope means that we are going to go up 2 units. And the 3 down on the denominator means we're going to go to the right 3 units. So up 2 units and right 3 units. So let's go ahead and go to our y-intercept, and we're going to do the numerator first. It goes up 2, so 1, 2. And then we're going to do the denominator. It means we got to go to the right 3. 1, 2, 3. I'm going to put a point right there. And I'm going to go ahead and connect my dots. So here's my line. Now notice we got a couple different things going on. This was the y-intercept down here, right? This negative 2. But this one has a real nice clean x-intercept. And so I'm going to go ahead and put an arrow pointing there. And so my x-intercept is at, looks like 1, 2, 3. Is at positive 3. So I would say if I wanted to write this x-intercept, it would be at 3, 0. Now, also remember that sometimes instead of calling it the x-intercept, we also call it the 0. But when we call it the 0, we usually just put x is equal to 3. We just give the x value in the ordered pair. All right, let's go ahead and graph our last one. Now, you're going to notice this one looks different. You might be looking at it going, Mr. H, this doesn't have a y-intercept. There's no number there. Where do we start? Okay, well, I want to tell you that there really is a number there. But the thing is, in math, whenever this number appears in an equation, a lot of times we just leave it off. And that number is going to be 0. Anytime you see an equation like this just means it's a proportional situation. It means it goes through origin when it crosses the y-axis. And it actually has a plus 0 at the end. But we leave the plus 0 off because it doesn't necessarily have an effect when we're doing calculations. So know that even though it says y equals negative 1 over 2x, it's really y equals negative 1 over 2x plus 0. So I'm going to go ahead and circle it, right? That is my y-intercept. That's my b value. In this case, b is going to be equal to 0. And that's an easy place to put a starting point because it's origin, where the two bolded axes cross each other. So I'm going to put a point right there, and that's our starting point. Now, do notice that our slope is negative, so my m value is going to be negative 1 over 2. Now, this is important because it's negative. That means instead of going up for the numerator, we're actually going to be traveling down. So I'm going to write right here, down. And right here, there's 2 on the bottom. That still means we go to the right. 2 units. So I'm going to put my pin on my starting point, on my y-intercept. And now what I'm going to do is I'm going to go ahead and I'm going to count down 1 unit. So down 1. And then I'm going to do my run, which is the denominator, which is 2. So I got to go to the right 2 units. 1, 2. I'm going to put a point right there. And I'm going to use my ruler and connect the dots. Alright, my line is now graphed. I want you to notice 2 things that we have here. One of them is I'm going to go ahead and mark my y-intercept. So I'm going to put an arrow. In this case, my y-intercept is 0, 0. It goes through origin. And if I look on here, in this case, that also happens to be my x-intercept. So anytime we have something that's proportional, your x-intercept and your y-intercept are going to be the same. It's 0, 0. This is also known as a 0, and if they asked on the test, what is the 0 equal to? Well, our 0 in this case is just going to be, let me put an arrow here, x equals 0. So now you know how to graph proportional and non-proportional relationships, right? And these are actually linear equations. I just say proportional and non-proportional because this was proportional and this one's non because it doesn't go through origin. That would have been an 8th grade standard that you learned. But you know how to graph them, and you know how to convert your slope into a fraction if need be.